welcome back to our magic tutorials for chemistry. So today we are going to learn about the preparation and properties of ozone. Correct? Ozone, we know the formula, it is O3. Correct? O3, and it is an allotropic form of oxygen. Allotrop of oxygen. So let's check the preparation. Only one preparation is there. So it is subjected, I have just written the point here. So it is subjected through a slow stream of pure and dry oxygen. How it is prepared? By subjecting a slow stream of pure and dry oxygen through electrical discharge in Siemens ozonizer. Why the name is given as ozonizer? Because ozone is produced. It is named as Siemens ozonizer. So Siemens ozonizer, it is like a chamber in which the earthed iron tank is used. Earthed iron tank. Earthed iron tank is used, which is filled with water. Which is filled with water, and it will, what will the water do? It will cool the apparatus. Correct? It will cool the apparatus. And this earthed iron tank, why the name is earthed? So that it will be properly, earthing is done, grounding is done. Okay. This earthed iron tank, it consists of aluminium tubes. Okay, it consists of aluminium tubes, and electric current is passed, that is 8000 to 10,000 volt. Correct? You know it is a high volt. So that's why we are using water inside this tank to cool the apparatus. Correct? And at that time when high voltage is provided, O2, oxygen, it breaks and it forms ozone. Correct? We know that oxygen, it has a double bond, O double bond O. Correct? It is a double bond between two oxygen atoms. So lot of energy is required to break that bond. Yes. So what will be the enthalpy change? That is plus 142 kilojoules per mole. 142 kilojoules per mole. So high voltage is supplied. So to cool the apparatus, we are taking water in the tank and we are providing high voltage. Why? Because there is a double bond in oxygen. To break a double bond, more energy is required. Correct? And 10 to 15% of oxygen will be converted to ozone by this method. Correct? And whatever ozone you are getting as the product, it is called as ionized oxygen. Why? Because O2, any molecule splitting, it will form ions or atoms, right? So it is called as ionized oxygen. Why? Siemens ozonizer is given to the chamber where it takes place. 10 to 15% of O2 will be converted to O3. Now I have written a word here, that is dry oxygen. Correct? Slow stream, that means slowly it is passed. Dry oxygen word I have written. So what it is? Dry oxygen, the word means the gas is passed through a tower, 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 which consists of the drying agents. Correct? How to dry a gas? Correct? So what it is done? It is passed through a tower in which drying agents are present. And what are the drying agents? The drying agents are phosphorus pentoxide, and one more dehydrating agent, that is making it dry, removal of water, that is one acid. Just pause the video and think one acid. You will be thinking about many acids. Okay. So one of the drying agent, that is an acid, that is sulfuric acid, concentrated sulfuric acid. It will act as a dehydrating agent. So how to dry the gas? How it is dried here? Removal of water. How? It is passed through a tower correct, which consists of the drying agents, and the drying agents used are phosphorus pentoxide or concentrated sulfuric acid can also be bubbled into the gas. Bubbled into the gas, or the gas can be bubbled with the gas can be bubbled with sulfuric acid, concentrated sulfuric acid. So it will become dry. So this is the preparation of ozone. You just have to remember the sentence, no need of explanation of the process, correct, and the equation we will write, that is O2 to O3, oxygen to ozone, balancing the equation 3 to 3 to the 6, 3 to the 6. Correct. So this is only one of the preparations of ozone. Only sentence you have to remember and the equation, that's enough. So we'll check the properties. Just if you want to make a note of it, make it. So let's see the properties of ozone, that is O3 formula. So the first property, it can exist as solid liquid gas, just like oxygen. It can also exist as solid liquid gas, but different colors. So if it exists as pale blue color, then it is in the gas form, gaseous form. It is existing as dark blue color, then it is in the liquid form. Okay, and if it exists as violet black color, then it is in the solid form. So ozone can exist in all the three forms in different colors also. Correct. It has a strong characteristic smell. It has a strong characteristic smell. That is the odor. Strong characteristic smell. It is poisonous in nature. It is poisonous in nature. Okay, it is poisonous in nature. It is also environmental pollutant. Environmental pollutant, which causes pollution, right? That is pollutant. Okay, it can be used as a disinfectant. Used as disinfectant. Correct. Aqueous ozone, if it is in the aqueous form, I'll just write it as aqueous ozone. It is used as a sanitizer for drinking water. Okay, now you will be thinking why the words, opposite words are written. These 4 points, hope it is clear to you. See this point, I have written here it is poisonous, it is environmental pollutant, but it is used as disinfectant, and aqueous ozone is used as a sanitizer for drinking water. Correct? One side I have written poisonous, here I have written the uses also, it is good also. How? So if it is in the concentrated form, okay, if the concentration is high, then it is harmful. In very less amount, in very less concentration, it can be used as a disinfectant and it can also be used as a sanitizer. And if its concentration increases above about 100 ppm, ppm is parts per million, then it is harmful and it will cause irritating, the throat will be itching, irritating, coughing, breath problems. Correct. So it is poisonous if its concentration is more, but it can be used as a disinfectant, and aqueous ozone is also used as a sanitizer in very low concentration. If its concentration goes beyond 100 ppm, then it is harmful. Okay, breath problems, nausea, then coughing, these all are the problems. And moreover, it can also kill many microorganisms. It can kill single cellular microorganisms or multicellular microorganisms also. Fine. So it is useful as well as harmful. In more amount it is harmful, less amount it is useful. Let's check the next property. So the next property, that is the ozone, it is thermodynamically less stable than O2. We are using the word thermodynamically. That means we will compare it with the thermodynamics. Okay, thermodynamics of 11th standard. So it is thermodynamically less stable I will write, less stable than O2, oxygen. It is less stable thermodynamically than O2. So what is the reason here? What is the reason? Delta H, it is negative. Why it is negative? What is delta H? Change in enthalpy, change in energy. Correct? Why it is like this? Because on decomposition, O3, on decomposition, it forms O2. Correct? On decomposition, O3 forms O2. Decomposition, heating, right? It forms O2. Decomposition, it is what? Endothermic or exothermic? Exothermic. Heat will be released. Exist. Heat released, going out, exit, exothermic. So decomposition reactions, they are exothermic in nature. So O3 on decomposition forms O2, which is an exothermic reaction. If it is exothermic, means delta H value will be negative. Correct? If you remember the previous preparation that I have written, correct, O2 to O3 preparation. If you remember, O2 to O3 preparation. Here the value of delta H is what? Positive 142. Positive 142. Why? Because it is endothermic. You are breaking the bond between oxygen and forming O3. So breaking of bonds, you have to provide energy, so that is positive. Here release of energy, that is exothermic. Okay, so delta H is negative in this case. Delta H is negative. Now O3, it is ozone, O2 oxygen. Again both are gases, right? So when it is decomposing and forming another gas, that is O2, what will happen to the molecules of that gas? They will be roaming here and there, correct? They will be colliding with each other, right? They will be colliding with each other. They will be randomly moving. So what is happening if they are randomly moving? The entropy will change. So entropy, we denote it as S. Delta means what? Change in entropy. So change in entropy, it increases. Correct? Because the molecules, when one gas is changing to another gas, what happens? The molecules will be randomly moving. They will collide with each other. Correct? And disorder or randomness here and there. What it is? Entropy. So at that time the entropy will be positive. Positive value. We are not discussing about the values and all, just telling it will be positive. Correct? Okay. Now thermodynamic, we know the relation delta G is equal to delta H minus T delta S. What is delta G? Gibbs free energy. Delta H is the enthalpy change. T is the temperature. Delta S is entropy change. Now just put the values and means just the positive and negative signs you put and check. Delta H is negative. Delta S is positive. So what will be the value of delta G here? Will it be positive or negative? Pause the video and tell me. Okay. So I think you all just thought about the answer in your mind. So delta G value will be negative. So if delta G value is negative, what it will be? Will it be a spontaneous or non-spontaneous? Delta G value is negative. That means it is a spontaneous reaction. It is a spontaneous reaction. Spontaneous means what? Which happens on its own. The reaction which happens on its own. That is spontaneous reaction. Hope it is clear to you about this point. Just if you want to make a note of this, you can. Okay, check the next property. O3, it liberates oxygen as well as nascent oxygen. I will write here nascent oxygen. Ozone, it liberates oxygen and nascent oxygen. What is this nascent oxygen meaning? Nascent, we always write it in the square brackets, correct? It is a monoatomic oxygen, one atom. It is reactive in nature and unstable, but it is unstable. It is reactive but unstable than oxygen. Okay, if you compare this to nascent oxygen, it is reactive but it is unstable than O2. Okay, what is the meaning of this word nascent? That is freshly prepared in a reactive form. It is a reactive species, right? So it is freshly prepared in a reactive form. That is called as nascent. Okay, so last property we will discuss, that is ozone. It is a very good oxidizing agent. Okay, ozone is a very good oxidizing agent. So it will oxidize iodide ions to iodine, and it will oxidize lead sulfide to lead sulfate. Correct. Now sulfide, sulfate, sulfate, sulfite, that all formulas, don't get confused. I have already uploaded one video for these formulas and names of these ions. Okay. So ozone, it is a good oxidizing agent. So two examples, one is the ionic equation, one is just the equation I have written. It explains us why ozone is a good oxidizing agent. So ozone, it is an oxidizing agent, OA. Correct. So the other reactant, it will be a reducing agent. Correct. Think, if ozone is oxidizing agent, the other reactant, water, you leave it, the other reactant, it will be a good reducing agent. That means if it is a reducing agent, it will undergo oxidation. Correct. So let's prove how it is undergoing oxidation. So iodide ions, instead of iodide ions, you can also write it as Ki, then here it will become KOH. So you can write it in the ionic form, the equation, or instead of iodide you put Ki, OH you put KOH and balance the equation. Okay. So iodide, what is the oxidation state here? -1. Check on the right hand side, I2, iodine. Okay, iodine is produced. Now this iodine produced, what will be the oxidation state? It is in the elemental form. It is not combined with any other element. So its oxidation state will be 0. Correct, as I told you, it should undergo oxidation. So -1 to 0, what is happening? Oxidation, increase in the oxidation number. So it is undergoing oxidation. Okay. Check the next one. Again, O3 is a good oxidizing agent. So over this compound, it will be a reducing agent. Okay. So it should undergo oxidation. Let's find the oxidation state of sulfur here. So what is for sulfur? Here it will be -2. And here it will be Pb, that is +2 we are taking, plus X for sulfur, we don't know, plus 4 into -2, that is for oxygen, equal to 0. So that will be +6. So again you can see -2 to +6. What is happening? Increase in the oxidation number. So it is undergoing oxidation. Correct? So these two equations, it proves that ozone is a good oxidizing agent. Correct? You can make a note of this equation. Hope it is clear to you. Correct? So we'll go to the next property. What it is? Ozone, it will react with mercury element. Okay, ozone, it will react with mercury. Hg can react with O3. So what it will form? It will form Hg2O. What is Hg2O? Mercurous oxide and O2. Mercurous oxide and O2. So when ozone, it is reacting with the mercury, it forms mercurous oxide and oxygen. So what happens during this process? The meniscus of mercury is lost. Meniscus of mercury is lost, and it will stick to the walls of the test tube. Okay, it will stick to the walls of the test tube. Now what do you mean by this meniscus? Now if you have seen when you pour water, okay, water will always show a down meniscus, right? A down meniscus. And what it is called as? It is called as a concave meniscus. In water, it is a concave meniscus, down. Okay. But in case of mercury, it is always, if this is the test tube, it will be like this. So it is what? A convex meniscus. Meniscus means that layer, how it will be, the top layer. It will be convex in case of mercury. So when mercury reacts with O3, ozone, it forms mercurous oxide and oxygen. At that time, the meniscus, this meniscus, the layer, it is lost, and it will stick to the walls of the test tube. Correct? And what is this called as? It is called as tailing of mercury. Tailing of mercury. Just for your knowledge, I just told you about this. Okay, for 12th portions and all, this word all, it is not there in the textbook, but you should know this. So mercury will react with oxygen, ozone, it will form mercurous oxide and O2. At that time, the meniscus of mercury is lost, which is called as the tailing of mercury. Okay, in water it is concave meniscus, in mercury it is convex meniscus. It is called as tailing of mercury. But if you again shake it, if you shake the test tube, again the meniscus will be restored. Correct? So here we complete with ozone's properties. Correct? We will check for the structure of ozone, that is the last topic. Yes, so the structure of ozone, I have drawn the Lewis structure for ozone. Lewis structure for ozone I have drawn here. Hope you know to draw the Lewis structures. Okay, so I have put a double arrow, that means the resonance structure also you can draw. So what you will do, resonating structure, just the double bond you take it on this side, single bond take it to that side, easy way. Okay. So the oxygen will remain as it is, it will get a partial positive sign, delta plus, that is partial positive. This oxygen take it to that side. So how many electrons are there? 3 pairs of electrons which has a delta minus sign, with a double bond oxygen with 4 electrons. Correct? So This is a structure for ozone, and I have also drawn the resonating structure for ozone. So hope you liked this video. We have completed with the ozone, which is the second compound of group number 16 elements. Hope you like this video. Thank you all.